All right, let's look at the homework 7, problem number 30. All right, so let's see. So we have f prime given, and we want to answer a question about the original function f. All right, so let's look at this. Function is decreasing on the subinterval. All right, so if you look at the picture here, all right, f is decreasing, which means that the derivative should be negative. So you can see that starting from -1, and it stays below the x-axis. At this point, it becomes 0. It's still it flattens out the 1 instant, but it's still decreasing. All right, so we have we're gonna have to go from, I think they want open interval, so I'm gonna start from -1 to infinity. All right, let's check the answer. All right, we got that. All right, a function is increasing, so if it's above, so you can see that it's going to be negative infinity to -1. All right, so check the answer. All right, we got that. All right, function has a local maximum at, okay, so we want to find a local maximum, which means that the increasing turns into decreasing. So here, first look for the derivative where the derivative equal to 0, so we look for a critical number. In this case, critical numbers are -1 and a +2. -1, derivative turns from positive to negative. So increasing turn into decreasing, so you have a local maximum there. At 2, it's a decreasing turn into decreasing, so it's just at -1 you would have a local maximum, and at 2 there's no local maximum or minimum. So here answer should be -1 there. All right, let's check the answer. All right. Next question. Function has a local minimum. There's no local minimum, so answer part B is the answer. All right, and then graph of concave downward on the subinterval. All right, so this is concave downward, means that the second derivative is negative. If second derivative is negative, then the first derivative is decreasing. All right. So you can see that it's decreasing up to 0, then it decreasing start from 2. All right. So look, so we should put the interval from negative infinity to 0 and 2 to positive infinity. All right. So let's check the answer. All right. We got that. And concave upward, so it means that let's see, second derivative is positive, which means that the first derivative is increasing, so it's between 0 and 2. All right, so 0 and 2. All right, check the answer. We got that. All right, and I'll continue. All right, function has an inflection point. All right, so we have to think about the concavity change. Remember that it's a concave downward here, concave upward here, concave downward there. So concavity changes happens at 0 and 2. So we can see that this is going to be at 0 and 2. All right, so let's check the answer. All right, we got that. And we want to choose the picture. All right, so remember that first it's increasing and then turning into decreasing. All right, so here's increasing, it's not decreasing here. It's increasing, turning into decreasing, so B is promising. C, it's not increasing here. D is not increasing here. So B is the only reasonable one. So check the answer. We got that. All right, and okay, that's it. All right, I hope that this was clear.